So as we take on the primary functions of an operating system, in the first module, we're looking at general concepts or foundational concepts, and persistence or non-volatile memory is one of those things that an operating system must be capable of negotiating. It has to have the capacity to work persistence issues efficiently, or it really doesn't stand much of a chance of being a decent operating system, because a lot of the following material depended on some competencies with file systems in order to be able to navigate internals, low-level services, hardware drivers, and such. There was a good bit of file system knowledge that people needed. I think this semester we're going to take a hybrid approach. We're going to teach a few file system things along the way. And if you look at our modules, so you have an introduction and OS structures, then we deal with process and process synchronization. That would have a lot to do with concurrency, right? So when you're running multiple processes, and this is just another way of viewing it, when you're looking at processes those are active software applications, the definition of a service or a process is an actively running application, yeah? And you may have heard those terms before, processes and services, right? A lot of times when we have dysfunctions or troubleshooting issues within the realm of processes and services, and we have concurrency challenges, oftentimes it's a question of the level of privilege for execution. So you can take a service, right, that's associated with a running process on a deeper level, and you can take let's find a good one here. DHCP, right? So here's a good one. Can everyone see my screen?
Yeah, we can.
Yeah.
Yeah.
So one of the hallmarks of an operating system is its ability to concurrently operate. And that means that we have to be interconnected to access resources, not just locally in terms of the disk and file system, but and local memory, but also across a network. And from your days in, everybody here has already completed CSC 243, yes?
Yes.
Yes.
Yeah.
Shanoa, have you had CSC 243 yet?
Oh, what class is that specifically?
Digital communications and networking class?
Oh, yeah.
Okay.
Yeah, I had that class.
Okay. So you remember DHCP, it's the domain host control protocol. Its primary function, it straddles between layer 2 and layer 3. You have a client that connects to the physical media and has a MAC address, and it broadcasts using ARP. And address resolution protocol says, okay, what kind of IP address? Well, DHCP is the other piece of the puzzle that complements this. A device that connects to a network that connects to an active network has to configure a static IP address no one else is using, or receive an assigned address that no one else is using, and that's precisely what DHCP does. Now this is a low-level service, right? It's a local service, and it has system privileges, so it's running with pretty powerful permissions and privileges, right? And we're going to talk a lot about permissions and privileges. But if you were to double click this, come on now. Is it going to open services? There we go. So it's going to open the services MMC, and I'm going to scroll to DHCP. You used to be able to just double click on the thing and it would open. And maybe what they've done is made that less accessible for security reasons. Can everybody see?
Yeah.
Okay. Can everybody see this tab? What does that tab say?
Log on.
Log on.
Log on.
Yes, that's correct. So a local service account, the operating system has something called a local service account, but you can establish a privileged account separately. And there's a special category called a managed service account. We'll get into that a whole lot more when we start talking about other aspects of the file system that a competent operating system has to possess. On the whole, there's a standard. It's called POSIX, P-O-S-I-X. And in order to be POSIX compliant, the computer science and computer engineering industries and the IETF, the International Engineering Task Force, and the IEEE, these are professional standards and international associations. They codified and basically fleshed out how a lot of this stuff works. And one of the things that's important to understand is that services, operating system services, are critically important. There are dependencies. Can everyone see?
Yeah.
Yes.
So here you have some services or processes that are dependent upon DHCP, but in turn, DHCP is critically dependent upon two other services that are like lower level services. And so you have to have these hooks in place in order for DHCP to operate. The important thing to understand is that concurrency is critically dependent upon the privilege or permissions with which they operate. And you can use a local system account, you can use a specific account, or you can browse for other special accounts. And there's one called a managed service account. Does everybody see this piece right here? What's that about? What are all these dots? What do they represent?
Password.
Yes,
Your password.
exactly. There's a login credential, there's an account, and there's a corresponding password. But did you know that for security reasons, those passwords can expire, right? Depending on the type of account. You have to reset passwords or change them, yes? And so a managed service account is a secured account, and it's designed exclusively to empower better concurrency. This is a Microsoft innovation. The managed service account is also active between sister members of a clustered service. Has anyone ever heard of a server cluster? Clustered server, maybe?
Yeah.
Okay, so you have more than one server that does the same thing, and it's for redundancy and resilience. You have clustered services and clustered servers. You have a group managed service account. We'll get into more of that later. But the point is that if you use a managed service account on a single system or a group managed service account, and you configure a password properly and just get it going, it automatically changes and updates the passwords between the systems in order to secure that service. And it's that account that provides the privileges and permissions that the service or the process needs to function correctly. That gets into system resources. Okay, so you have multiple services. It's kind of like a juggler, right? You have to juggle. If you notice the progression of our modules, we talk about basic OS structures first, and then we talk about process management and services that would have to do with the concurrency piece. and the virtualization piece. So when we talk about OS structures, we're virtualizing our physical components to create virtual representations of those components. And that's something that we're going to cover in just a minute. And then we have the concurrency piece, and then here's the persistence piece, okay? And what we're going to do is address file system and disk drive criteria as needed as we work through here, okay? But we'll do a deep dive here when it comes to file system design and file system principles. Any questions about how we've laid out the content of our course? I may or may not have shared this with you last week, but when we get through the end of module 2, the intent is that we should be somewhere near midterms. And if you're going to be resubmitting or making up for any work, you'd want to have that done as much as possible. I did extend for everyone the deadline for the textbook submission. So you have a little more time through the end of this week, even though the header of the assignment still shows this morning's deadline. By this time, everyone should have laid on to or laid hold of an authentic copy, an authorized copy, a legitimate copy of the textbook. A legitimate copy of the textbook. And we're going to be referencing this quite a bit. There are some ancillary materials. There's a virtual machine that you can install and run and use in some of the textbook sections. And so we're going to try to tap that more this season. And so if you have not yet done that, by the end of the week, I need you to, post this. So it's still open if you have any problems with that. I did want to talk to you about and what is it you recall from last week about this assignment? Did we talk anything about this assignment other than a generic reference on this screen? Did we go, help me remember here. I have 5 different classes. I want to make sure I get it right. Did we cover specifics about assignment 1.2?
I don't recall us going over.
Okay. Well, this is it's an older YouTube video. When you watch it, you'll go, oh, not this again. Because you might remember this from previous courses. It's the same process that you go through to prepare your own personal technology so that you can perform some of the assigned tasks and solution steps. And so it's really important for us to gauge where you are with your own personal technology. If you have a Mac, there's better detail about what to do with your Mac to meet the requirements. But basically, there are 4 separate criteria, right? And each of these are worth 1/2 point. And one of the things I would encourage you to do is to close all of your applications. And in particular, when you open your browser, if you have 27 browser tabs, hello, am I speaking to anybody in the audience? 27 browser tabs, right? That you would close each of the browser tabs. And then power off your system. And if you can even remove the battery. A lot of times laptops will not truly power off. They're more like a hybrid sleep mode. They want to have quicker startups so they can have bragging rights. They're bigger and badder than other brands. And so there's a lot of tricks when it comes to whether or not an operating system is truly off. And then what you want to do is sign in to your logon. And before you do anything else, you want to see about this assignment. So don't start multitasking or doing other things. Why? I'm going to ask you to capture, this is one of the 4 screens, right? So basically, we're going to walk through this real quick. And you may recall we did something like this previously. You click on the Performance tab, and you want to select the CPU option. I'll see how much memory you have and the type and capacity of your processor. This is important to gauge if we're looking for ahead to solutions that require the use of virtual machines. Okay, everybody with me?
Yes.
Yeah.
Okay, so this is one of the screenshots, and you can clip this or you can use Alt Print Screen, and then you open up. I mean, you can capture that separately and save it as a JPEG separately with the title that we have here, your first initial and last name, and then CPU, memory, and capacity, right? CPU and memory capacity. What's the next one? Total versus available disk. Now, what we're looking for is this view where you open up your File Explorer, and the default settings for your File Explorer can be problematic because there are certain file system criteria that don't appear by default with every, well, the default settings for File Explorer don't show everything you need. For example, the file extensions are not always there. So what you want to do is select where it says this computer or my computer, and you want to click on the view menu and you want to select details. And that's going to provide additional information about creation date and some other useful criteria. You're going to go back into the view and select file name extensions and hidden items. Now, every time you check the box, the menu disappears. It's kind of a nuisance issue. You're also going to select this and go to change folder and search options. Select the view tab. And then you're going to select each of the options here so that it appears just like this. First one is unchecked. The next 4 are checked. The second radio button is selected. The following 3 are unchecked. If you make any changes, the apply button will come out of gray, and then you can click apply and then OK. And then what you're going to do is take a screenshot of this. So you're going to grab a screenshot of this. I'll print screen again, right? And you're going to save that. Any questions so far? Now, I recommend.
No, for me.
Now, thank you. I recommended to you that you close down your system and close off all your applications before you do the CPU memory thing. And I'm going to make a second recommendation, and this is going to seem bass-ackwards, okay? It's going to seem like I'm putting the cart before the horse, and I'll explain. What you don't want is to show me a CPU and memory capacity that are maxed out because you're juggling so much. It's going to make it look like if you have a CPU and memory utilization that's higher than mine, I'm going to have a conversation with you about, you know, okay, how do we get your personal technology roadworthy for the tasks ahead, right? This is a 400 level course, and you're going to be expected to do some serious things on your own personal technology and some serious things with virtual machines that are running on a platform that you access remotely. You're going to be doing those things simultaneously, and you may have to record some things or capture some screens. You may have to, you know, log some services, right? So there's going to be some juggling that your laptop or PC may not be accustomed to. If you're running a bunch of stuff, your CPU and your memory are going to look like they're maxed out. And if I have a system that a student submits for, and the CPU and memory are higher than what you're seeing here, and nothing is running, then it's usually an indication of an exploit or malware, right? And in some cases, they're very low level. There is a special kind of exploit called a kernel level exploit, and it is lethal because it is undetectable. Kernel level exploits actually modify the output of the task manager to mask their activity. This says that my disk is actually working 5 to 7% of its capacity, right? Everybody with me?
Yeah.
But if I had a slow system, if I had a very slow system, and I looked at the disk light on my laptop or the disk light on my PC, and it was flashing like a Christmas tree. It was constantly blinking away. I would know that something is off because the screen shows, oh, I'm really only, I'm coasting along. I'm just liming here. I'm just, in operating system terms, I'm liming. It's just an easygoing day, 5 to 7%, right? Well, that wouldn't make for a constant activity light flashing all the time on your disk light and a slow screen, would it? You get what I'm saying? That would happen if you had a kernel level exploit. You were infected so deep in the operating system, and some of these things are so sophisticated, they can feign the output that's normal to mask their activity. And that's where we live now. That's the world we live in right now. Okay, so here's the other piece. We just talked about the file system. We said, yeah, you can do this and capture the screen, and then that's the second submission that we need. But in the same vein that I suggested, you close all your applications, you power your system off, and you reboot. I'm going to suggest a second thing you do before you even begin assignment 1.2. Okay? A second thing. I'm going to ask that you go to the control panel. So if you don't have it on your start menu, why don't you do this with me right now? You're going to use the control panel constantly. If it isn't on your start menu, you're going to want to put it there. You're going to type control, and it's going to appear. And the first thing you're going to want to do is right click it and pin it to the task, pin it to start if it isn't already there. But we're also going to want to open this. And I want to tell you that whatever you use on here, you always want to right click it and run as administrator. Let me repeat that. You want to right click it and run as administrator. If you can. If it allows you to run and as administrator, then that's what you want to do. Now, in some cases, you can't do it from within control panel, but if there's a tool like disk cleanup and you pin it to your start menu, right? You pin it to start, and then it's in start, then you can run it as an administrator, okay? And the operation of the utility is much more stable and reliable because you're running it as an administrator. Even if you're running it with a login as an administrator with administrative privileges, okay? Well, let's get back to this thing. I want you in control panel to access this. I would advocate before you do the second thing, well, so it makes sense to close all your apps and close all the tabs, but then come in here first, right? Now, why don't I put all this in here? I have found over the years that when I put all this extra information in the assignment, a lot of students are rushed at the beginning of the semester. They don't read half of it. And I thought, okay, this is important enough where we want to have some quality time in class to talk about it. All right, so here I am in my programs and features. There's another thing in here, Windows features on or off. You're going to find that things are turned on you don't need. You're also going to find that there are applications that are installed you may or may not be familiar with or you just don't use anymore. Did you know that when you do the last step of your assignment, the disk cleanup, or the last two steps, you're loading recent updates, you're completing the installation of recent updates, and then you're also performing disk cleanup and defrag. Did you know that both of those activities happen much faster in much less time if you take out the trash? You need to take out the trash. If there's stuff that you see in your list and you're like, what is this? Oh, you know, I was home with my kids over the summer and they had a brother printer. I don't need that anymore. What you want to do is uninstall the things you don't need. You want to check and see if there are Windows features that are turned on. In particular, there's one that's insidious. Some printer software, and I won't mention any brand names because I don't want to be sued, and this will be recorded out on the open internet. HP. HP. I'm sorry. Yeah, I can't mention the brand name specifically of certain printers, but they love to install a web server on your client operating system so that you can do all sorts of cool printy web things. And if that's checked, you're going to want to ask, do I really want a web server running on my laptop? And you'd be shocked at how many times people have IIS checked there. That's just a serious thing. I want you also to notice that there's an option to run virtual machines if you're running Windows 10 Professional Edition, Corporate Edition, Education Edition, if you're running a Workstation Edition, and we'll talk about the differences between versions and editions in an operating system shortly. But if you have a Pro version or an Education version, then Hyper-V is the built-in Windows feature that allows you to create virtual machines. And we'll be using Hyper-V a lot, along with VirtualBox. And on the Mac side of things, right? The point is I want you to scroll down here and I want you to see if there's stuff that you don't really need. There are things like Telnet Client. That is a sitting duck. You can, what's Telnet? You can go to the command prompt, right? You can type in CMD, open a command prompt, and then Telnet to another machine, except everything that flows through there is unencrypted. You would want to turn that off. You don't want that on your machine. So it's going to make a change. But then there's one other place that you need to check to see if there are unknown or unused apps, and then remove them before you do all the rest of this. You're going to want to go to the Start menu, because beginning with Windows version 8, they added this cute little way of installing apps off the Start menu. And here's something that's a real nuisance. You can have, did you know you can have stuff that's installed here like this? Everybody see this? Does everybody see this?
Yep.
That's an app installed from the Microsoft Store, and it runs off of the Start menu. But do you see hash tool in the list here? Nope. So what am I saying? You go here, but then you also go here into apps, and then you look at the apps and features, right? And you find something. If you see something that you're like, what was I doing with this? I don't know why I was using this. Select it, then select the option uninstall. And you want to do all of that before, actually, you want to do all of that before. See there, if you have unused, oh, I did this last year and this thing, oh, and it's running in the system tray. Why do I have, look, I have brother stuff running in my system tray. That's taking up CPU and memory, right? So you're going to get a false read on your CPU and memory and whether or not you're exploited or not exploited, what your true capacity is, how healthy your OS actually is, how much disk space, all of that takes up disk space, right? So when you uninstall those things first, and then you close all your windows and you're running apps, and then you power off your machine, and then you start this process, then you're doing pretty good. At that point, if you're running updates, here's the thing I would share with you. True or false? It makes no difference how long the updates process runs if you have a lot of extra software on your system. True or false? I'm going to repeat the statement. Is it true or false that it makes no difference to the length and complexity of the update process whether you have lots of applications loaded on your system or just a few?
Makes a difference. right?
Yes, it does. It makes a huge difference. Thank you for going out on a limb. Here's why. When you install some of these software packages, they load extra things under the hood, which supplement the resources of the operating system. In fact, according to Tony Gaddis, and that should ring a bell, this was the author of the book, Getting Started with Java, right? Everybody remember Tony Gaddis with fondness? CSC 117, CSC 118,
Yeah.
CSC
Yep.
242, right? Tony asserts, and he's pretty much an industry, he is an industry subject matter expert, right? So as far as our industry is concerned, we consider Tony Gaddis to be a subject matter expert. Tony says that an operating system isn't just the OS, it's also the utilities that are bundled with the operating system and the development environments that are created to work with those internals. So what are we saying? You have APIs, you have application programming interfaces in every OS, and just to come full circle, right? If we're talking about OS structures, right? This is one of our student learning objectives. It's like, okay, what are the main components of an operating system? And among those, you have this thing called the kernel. You have a hardware abstraction layer, right? We'll show you some diagrams of that in a little bit. But Tony Gaddis says, okay, it's not just the operating system. There are a suite of utilities that are built to work with the OS. That's a primary component. And then beyond that, you have development environments that are constructed to utilize the APIs and the assembly language, the low-level code, the system calls, right? There's all sorts of ways to describe this. The low-level system calls that you can utilize in your programming language. Your programming language is going to interact with the system calls, and you have to know something about the operating system to use those efficiently. If you have an install list that has older software, you're probably going to have a lot of older operating system supplementals. These Visual C++ redistributables are notorious for being outdated, requiring lots of patches and fixes and bug. They got to kill a lot of bugs, right? And the new versions of the operating system come out, and then these things don't run anymore. And then the software doesn't run anymore, right? The software stops working. So then you have to update the software. You have to update the operating system components. The update process is horrific if you haven't taken the time to weed your garden. Okay? So I'm going to expect a great deal of you. I know you've done this before in previous classes. You're going to find that I am kind of a Nazi. I'm going to be very picky about what I see when you submit for this assignment, because this is a senior class and it's 400 level, and we're going to be doing some cool stuff. But you don't want to get frustrated part of the way into the semester because your personal technology is not up to the task. Okay? Any questions so far? This YouTube is dated. We mentioned that already. When you watch the YouTube and it walks you through the process, it may smell and taste in a very familiar way, like, oh, I've had to eat this before. But what it'll show you is what you need to do for the updates, and it'll show you a specific build. This is what you need to have. When you go to your settings and home, and you go to system, you're going to want to access about. And it is this screen that we are most, this is the third, I'm sorry, not the last, the third criteria for 1.2 assignment. This is really important. If I don't see 21H2 for Windows 10, that's a problem. Now, if you're running Windows 11, you're fine. Just make sure you're running the latest version of Windows 11. And I'll know because I'll have the OS build on my own Windows 11 machine. Any version of Windows 10 should have the same OS build. If it doesn't say 19.0.44 in the first 5 numbers, you're not even in the ballpark. It most likely won't say 21H2. It'll say 21H1 or 20H2. It'll be a previous version of the operating system. Microsoft started doing what Mac systems do. They give out free releases of the new operating system. That's just good for everybody. The second cluster of numbers, the next 4 digits, tells me if you're absolutely the latest. So if in terms of being current, I'm on 21H2 if I'm running 19.0.44, and as of yesterday, if I updated completely, I have 1889. That's going to be a part of this class recording, and when you're referencing this one, man, I hope you're not showing the same build from last year or the year before, okay? Because this is from a previous season. Same steps to follow. And it does go into some detail about disk cleanup and defragment. There are some extra steps that you take. There's a hidden tab. I don't know if you recall this from previous semesters, but you want to run disk cleanup and defrag. If you're on a laptop, you want to make sure that you have turned off. Everybody see the skinny button down here? See the lower right corner? Everybody see the lower right corner?
Yeah.
Okay, so there's this ellipse, and then to the right of it is this slender button. If I tell you to click the skinny button, you put the tip of the pointer right on the skinny button, and when you do that, it minimizes all of your open windows simultaneously. That's really cool. So if we're working together and we're walking through some things, I'm going to close some of these windows just to keep stuff sane, right? Reclaim some resources. Okay, I've disabled Telnet because I don't want it. I'm going to close my services and close this, close that, close that. Power. Before you do the disk cleanup and disk defrag, if you have not changed your power options, you can access them through personalize, or the better way to do it is here. One thing you want to check is to go into the system option, select power, and you want to make sure it says when plugged in, turn off after, never. Sleep. When plugged in, PC goes to sleep after, never. If you engage disk cleanup and defrag before you do this, the power management functions of your laptop will kick into gear, especially if it's not plugged in. So make sure it's plugged in, then change these 2 settings, then go into additional power settings, then go into change plan settings, then go into, you should see the same thing reflected here, old school in the old control panel, but then there's an additional option deep under the hood, change advanced power settings. And this is where you want to make sure that under hard disk, the default setting for hard disk when it's plugged in is pathetic. It still puts the hard disk to sleep. Even with this stuff right here, oh, the display doesn't turn off and the computer isn't put to sleep, but the hard disk stops spinning. How can you defrag the hard disk, right? So you're going to turn off the hard disk after when it's plugged in, 99999 minutes. Everybody see this? I don't want you to experience that needless pain. And then down here, another thing too is that laptops like to conserve power, and they don't, when you're doing some real work, you don't want your laptop processor to be sucking along with, you know, oh, it's trying to conserve the battery. Another thing it does is the plugged in state for minimum processor is terrible. Change it to 25%, or if you have a relatively clean hard, you know, if you have a clean laptop and the fans work well, you could put as much as 33% in there. With these settings changed, the defrag and disk cleanup processes should should run very quickly. But, you know, in earlier classes, lower level classes, people submitted for this optimizing your personal technology, and I accepted what people did for the most part. In this class, there's going to be a great deal more scrutiny, okay? And it's really important that that I get a sense of how healthy your personal technology is, okay? Are there any questions about the 1.2 assignment? One point 3. Everyone here has had a previous class where we've done an article summary, yes? We're almost ready to take a break. We are about to take a break. I just wanted to comment on this. You're going to want to find something interesting about operating systems or operating system design or operating system principles or new operating systems. You can also search for articles on firmware. So another name for OS or operating system is firmware. So if there's some interesting stuff out in research or in industry journals, industry magazines, right, about the firmware associated with intelligent connected devices, you know, the Internet of Things. You have all these connected devices in your home. What about the firmware on your Alexa? I have a Fire TV. And is everyone familiar that you can update the firmware for your Fire TV? Does anyone else have a Fire TV, an Amazon Fire TV? Or a Roku? Or an Apple TV?
Yeah.
Okay. Yeah. So every night I finish watching a favorite program with my family. I go to the maintenance option to about to see if there's a new update. And lately, every other day, there are new updates. Because of the war with the Ukraine and because of some political tensions with China, there are an awful lot of really weird things happening in the hacking universe. And the operating system is like a really juicy target. And so there's a lot of patches and updates for firmware on a lot of devices. That includes Wi-Fi routers, intelligent assistants like Alexa, smart thermostats, wireless video cameras, you know, it goes on and on and on. It would be good if you found something that fascinates you and then it's interesting. And then of course you have, you know, how to go about the summary. It's the same format as last year, 2 paragraphs. The first paragraph is about the article itself. What does it relate? The second paragraph is about relevance. Why is that important? Who should care? Why should I be interested? Or who among the general population would be most interested, right? It's a relevance. It's a matter of relevance. Those are the 2 paragraphs you need to write. Please avoid copy and paste. I will be doing safe assign. So if you're in the habit of doing copy and paste and rushing, this wouldn't be a good thing to do. I did include a sample article from Wired Magazine, which may look familiar again, and a sample article summary, just so you could see how I did the summary for that article. If you have any questions about the article summary, please don't hesitate to let me know. Any questions about 1.3? Okay. Please take a moment to unmute your microphone and tell us you're still with us. We're going to take like a 2-minute pause, just 2 minutes, and then we're going to come back and we're going to get into some material. Okay? Everybody with me?
Yes, sir.
Okay.
Yes.
Okay. Heard from 3. Need to hear a 4th. I'm going to pause the recording. So I'm going to run through a couple of slides from our Passy Do So, the free or open source textbook that is available online, because it's useful to provide an overview of the structures of an operating system. But then I'm going to shift gears and use our current publisher so that we get both, because this is, again, just generic concepts is what we're shooting for here. I will post a copy of this in addition to so yeah, this is Andrea and Remzi, our Passy Do So. They're computer engineers, and operating systems are hugely important for for computer engineers, because their discipline focuses primarily on hardware. And computer scientists are keenly interested in operating systems because their primary focus is applications. And what you're going to see here is that we sit between those two. Can everybody see the screen?
Yes.
Okay, so we've already shown you a drawing of this. Operating system sits between applications and hardware. If you're coming at an operating system as a computer scientist, you're coming in from this direction, from the top down. If you're a computer engineer, like our Passy Do So, you're coming up from the hardware. And there are some interesting and related interests between operating system and hardware, in particular assembly languages, okay, which are specific instruction sets for a given digital component that also has hooks on the other side for the operating system, right? So the operating system is defined as the software. So technically it is software that is created typically with certain programming languages or development environments. You do not see an operating system designed exclusively in Python. That just doesn't happen. C, the programming language C, and in some cases C++ are used, and C# by Microsoft. Java can be used for virtualized OSs, but generally speaking, Java is really more suited for the development of universal applications that can run on different hardware platforms, which is why you have the Java virtual engine. That's old hat, you know about this. But Java was an attempt to create this universal utility because operating systems were not all that universal. They weren't all that good at translating hardware into a useful form that applications could use. If an operating system is POSIX, POSIX compliant, then you have less of that problem. Our Passy Do So, the computer engineers, they think of the role of an operating system. So abstraction is a role. In terms of a functional capability, that's called virtualization. Okay, so abstraction is the ability to take a physical hardware device and turn it into a virtual hardware device, where it's consistently the same virtual device, even though the different hardware brands and models differ. So that's a role of the operating system, not to be confused with its function. And roles are related to functions. Okay, so anything that's a physical resource, CPU, memory, and disk. So when you abstract memory and CPU cycles, when abstractions of memory and CPU resources are created, what does that look like? For the CPU, that's called a process or a thread. For memory, that's called address space. For a disk, that's called files. Does that make sense? Yeah,
Yeah.
Yeah, there's something about this that really resonates with me. When I first found this textbook, I thought, oh my gosh, not only is it free, but then it is very rich and takes a long time to digest. So, but I like the introductory part of the textbook. So it makes very good sense of this stuff. Now, the advantages of providing an OS abstraction. Of course, you can allow applications to reuse the common facilities and make different devices look the same. So everybody has a different Wi-Fi card in the different laptops we're all using right now. If we all looked at what we physically had for a Wi-Fi card that's connecting to our Wi-Fi, every one of those would be different. Any questions so far? Biggest challenge for abstractions is what are the correct abstractions? Who decides that, right? How does that work? And how much of the hardware should be exposed? Whenever you expose hardware, operating systems crash. They crash. They lock up. It's a huge challenge. How do you expose the hardware so you can access the resources without locking up the hardware so the whole thing just locks hard and rolls over and plays dead? And that actually happens, right? Okay, second role that an operating system provides is one of resource management, okay? And this gets into the file system piece. You have to be able to share resources well. The advantages of having resource management performed by an OS, right? So when you talk about roles, you know, what are its primary roles? There's two primary roles, abstraction and resource management. Don't confuse those with functions, okay? Advantages of the operating system: protect applications one from the other, provide efficient access to resources, and provide fair access to resources. Makes sense. Challenges: what are the correct mechanisms to do that? And what are the correct policies? You'll find out that one of these is very low level, near the hardware. The other one has more to do with the application level, okay? So when we talk about mechanisms and policies, you'll hear that again. Any questions so far? We're going to move very fast, and we want to get through these slides, and then we want to touch on the first concepts in the next for your textbook author. So OS organization, right? Virtualization. In the Arpasi Dussault open source textbook, there are ways to virtualize and demonstrate each of these, and they actually provide the code to build this. Very cool. So 3 pieces, right? The first piece, when they talk about an OS in 3 pieces, virtualization is the first piece. So you want each application to think that it has all of the resources to itself, meaning there are virtual hard disk, virtual CPU, and virtual memory available for each and every application. Now, let that sink in. That just takes a moment to get your head around. When you're virtualizing the resources, what you're really saying is everything that's running in my system tray has its own dedicated, devoted CPU, hard disk, connectivity devices, display drivers, right? Input, output, memory, right? That's what's happening. Virtualization, then concurrency. So this is more detail about those 3 pieces we've already discussed in our previous classes last week. The easier case for creating concurrent applications is that you hide concurrency from independent processes, right? So when you have independent processes, you're creating a process that's supposed to be autonomous, that doesn't consider anything else. Now that's dangerous because it's going to act like King Kong. It's going to act like Godzilla, right? But if you have a truly nicely implemented operating system where multi-threading works well, the processes have to interact, right? So managing concurrency in that context is much trickier. How do you allow processes to interact so they can pass data between each other. If they're completely independent, they're not interacting with each other. There's no data flowing between those apps or those services. Is that very practical? No, not really. This is where concurrency really is, this is where the rubber meets the road, okay? And we're going to spend a lot of time talking about interactive processes. Okay, persistence. So the information, right, talks about the lifespan or lifetime of the information. It has to last longer than any one running application. Otherwise, there's no value for what we do with computer technology, right? You have to reboot a system or it can crash. How do you handle crashes elegantly? This is perhaps the biggest and most important piece of persistence. You have mechanisms built into the file system that allow you to recover from a crash and troubleshoot what's going on. If you don't have an operating system that's rigged for that, it's called a journaling operating system. If your operating system isn't rigged from the ground up to be able to log low-level processes, to journal, it's a journaling operating system, you are so screwed when something bad happens, okay? All right. Yep, very slow disk performance. There's all sorts of ways to speed that up. We'll talk about that. And advanced topics, multi-process, we're not going to get into that, but virtual machines are a great way to explore this. It's important to study operating system principles so you can build your own, modify your own, tweak your own, tune your own, troubleshoot, write better programs, right? Fun and challenging. All right. Any questions about Arpasi Dussault? I'm going to put this out in the resources folder, or in our references folder. Okay. Now let's look at the other one. Can I hear something from somebody? Can you like wave at me, thumbs up, respond, say, okay, I'm still with you. I didn't have any questions. Pretty self-explanatory so far, right? Sort of.
So
I'm thinking this is pretty good stuff. And yes, all right, so yes, in the first chapter of your textbook, it's really important that you read through this stuff, that you get the big picture. We've been touching on many aspects of this, and I've been diving into my tool chest of Windows OS administration from my Microsoft certified days. But your textbook author is going to articulate those principles in a different manner. I expect you to know both the examples we cover in class with Windows that are drawn from my experience, and I want you to be able to know something about what's in the textbook, okay? So process, memory, and storage management, those are the three heavy hitting areas. All right, so one of the challenges and issues that you have to suss out or frame for an effective, efficient operating system is how you protect and secure the data. What kinds of things are you going to have in the vital organs of the operating system? The vital organs of an operating system, the heart and lungs, the brain, the liver, the kidneys, all the vital organs of an operating system are referred to as the kernel, right? So those are very low level and they're closest to the hardware. So those components of the operating system that interact directly with the hardware are kernel components. Kernel means, low level, close to the hardware, interacting with the what? Hardware. APIs, different layer, different level of the OS, that's facing out toward the applications, the system calls, okay? That's an important perspective to understand. Computing environments, open source operating systems. All right, so these are the chapter objectives. What is an operating system? It's an intermediary between user and computer. And the hardware, yes, okay, that's ringing a bell, yeah. The goals to execute user programs, making solving user programs easier, convenient to use, computer hardware and efficient manage. You know, that's the purpose of an operating system, right? Can be divided into 4 components. Hardware, this is the low level stuff, right? We call this the hardware in Windows. This is the hardware abstraction layer, or HAL, H-A-L, HAL. Has anyone ever seen or heard about the movie called 2000: A Space Odyssey? It's a really old movie, but it's a classic. There was a computer that basically took over and controlled. It's kind of like Terminator. It was like a preview of Terminator. Anyway, the name of the computer was HAL. Operating system controls and coordinates the use of hardware among various applications and users. So it's giving you a different view and a different explanation of the same concepts. And there's value in that because we want to come at an operating system. We want to come at operating system principles intentionally and deliberately from different angles using different words and different descriptions. Because that's going to help you on a deep level to get some stuff that otherwise doesn't click. Application programs and users. So the way that our author breaks down an operating system component, unlike Tony Gaddis, it's like, okay, you have the hardware, you have the operating system. Well, actually this tracks with Gaddis, right? You have the software and applications, then you have the users, the people on top. So that's, Gaddis gave you a diagram. This is giving you the basic bullet points. Any questions? Okay, everybody see this?
Yes.
Okay. So the user side of an operating system is what we'd call high level. Sometimes when we're talking about computer systems, we're talking about rings. It's a set of concentric rings with the innermost ring being the most privileged. That's the hardware level, or ring 0. So the greatest privilege is close to the hardware. And then as you get out here, the user interfaces for an operating system are further removed from the computer hardware. So why do we do that? We want to insulate the hardware from our users, or they crash the computer. I'm going to say that again. One of the main reasons for having an operating system is because we need to keep the users away from the hardware. If you write code to directly access the computer hardware, I hope you do a good job of it, because otherwise you're going to ruin things. Hackers know this. They're always trying to post bogus drivers for the hardware components, unsigned drivers. By unsigned, I mean digitally unsigned. Okay? Digitally unsigned. It is now 12:15. I'm going to stop here. We're going to pick up here with slide 9, but I'm also going to work our next course, our next class differently. So I'm going to jump a little between the next set of slides and our study guide and our solution. I'm going to post the solution you have to complete to prepare for your Module 1 assessment. And so we'll continue our review. So here's what we did today, just to recap. We took a closer look at the best practices for optimizing your personal technology. And everything that I shared with you is documented as a best practice for system administrators and help desk service support personnel, right? All right, just didn't call it that. We did briefly review our requirements for the article review, make sure it has something to do with firmware or operating system. We took a quick look at essential concepts for the open source reference that we're using from time to time. our Passy Dussault, and we found that sure enough, those are industry standards and consistent with the concepts of others, because Silverberg comes at it from the computer science perspective, although our Passy Dussault comes at it from the computer engineer's perspective. Much of the same concepts about what it is and what it does are the same. This is the thing I want you to sear into your conscience between now and Thursday. It might help to draw it. Just practice drawing it, because that will help with some things. I really strongly recommend that. Are there any questions before we clear? Any questions before we close?
No.
Okay, I'm going to stop sharing and stop